Addition and subtraction of vectors. The learning objectives. By the end of this section, you should be able to combine vectors through addition, combine vectors through subtraction, combine scalar vectors through addition and subtraction. Addition of vectors. Write vector A and vector B as column vectors. Vector A is 3, 1. Vector B is 6, minus 4. So what is vector A plus vector B? When adding vectors, join one end, or at the end of one, to the beginning of the other. So if we join these here, this is how physically we would add vectors. Write the column vector that goes straight from the beginning of A to the end of B. So what column vector would that give us? Gives us 9 minus 3. When adding vectors, the x components and add the y components. So A plus B is the x components of A and B, so 3 plus 6. And the B component, or the y components, 1 plus minus 4, which gives us the column vector 9, 3. The resultant vector is not affected by the order in which they're added together. So if we did vector B plus vector A, if we look at the resultant vector there, A plus B is still 9 minus 3. What shape is vector A plus B? All vectors are straight lines. When we add two vectors together, it isn't the path along the two vectors, it is the single vector. It's important to understand that. When we add vectors, it is a new vector in its own right, and it is always a straight line. Subtracting vectors. Vector C and vector D. We write the C and D as column vectors. So what would C minus D give us? To subtract a vector, think of travelling along it in the reverse direction. So C minus D. Now we join C with the beginning of D. So C minus D is we travel along C in the direction it is meant to be, and then minus D, we travel along it in the reverse direction. So write the column vector that goes straight from the start of C to the end of minus D. So C minus D gives us minus 4, 4. Again, to subtract column vectors, we subtract the x components and subtract the y components. If we now do that numerically, we'll see that we end up with the same column vector. But as with ordinary numbers, the result will be affected by the order in which they're subtracted. In the same way that 4 minus 2 is not the same as 2 minus 4. If we did D and then minus C, the vector would have the same magnitude, but it would have been a change of direction. It would be a different vector. So take your time with these. Lots of people struggle with vectors, and it's not that they're massively hard. It's there's lots of things going on at once. So work your way through these as best you can. And once you've done it, come back and check your answers. Pause the video now and work through that. Right, question 1. A plus B, 12 minus 2. Question 2. C plus D, minus 4, 1. Question 3. D minus B is minus 1310. C plus E minus E, or C plus A minus E. You add together the C plus E, and then we're going to minus the E from it, and that's what we'll end up with. 23.4. And now what we're moving into is scalar vectors. So to work out question 5, we've got to work out what 2b was, work out what 3e was, and then 3a, then substitute those values in, and then do addition and subtraction. And that's why people find it hard with vectors. There's a lot of stuff to do to work out the answers. Right, moving on to the slightly harder ones. Question 7. Again, with all these, we're working out the scalar vectors. Work out the scalars first, and then do the addition and subtraction. Question 9. Got that. Right. Hopefully you've had a bit of time thinking about this. It shouldn't have been too difficult. So x is 2, 3. Part 2, x is minus 3, 7. For question 3, x is minus 4, 5. As with all of this, if you've struggled with any of the questions in this video, work through it again. It wasn't a particularly long one, so you've got time. Go back over it and try and get there to the point where you're comfortable